historically, lots of aromatic compounds have common names. Show you a few examples, and with a methyl group bonded to a benzene ring, this compound is common namely as toluene, one of the solvent used a lot. And when you have an OH directly bonded to an aromatic ring, that's a phenol. And when you have a nitrogen substituted compound, it's an aniline. And with an aldehyde functional group, this compound has a common name as benzaldehyde. With a carboxylic acid functional group, this compound is having a common name as benzoic acid. And with a ketone functional group, this compound is commonly named as acetophenone. And this compound is a styrene, a very important monomer to prepare the corresponding polymer. And this compound, this alkyl aromatic ether, is named as anisole. And this guy is benzene sulfonic acid. And this last but not least, this compound has two methyl group bonded to the adjacent two carbon is referred to as the orthoxylene. Xylene, it refers to a group of compound that has two methyl groups bonded to the aromatic ring, also describes the relative position of the two substituents. Common names are quite useful in the organic chemistry, so I recommend you to memorize the common names in the first row. Okay, it would help you to read literatures and books. Moving on, we could also utilizing the IUPAC nomenclature rule to name aromatic compound. There are generally two different ways to name an aromatic compound. One is to name an aromatic compound as a substituted benzene. So basically, the parent name here is benzene, and you could describe what's bound to the benzene ring. For instance, the compound over here has a bromine directly bound to a benzene ring, and the IUPAC name for this is a bromobenzene. One word. Okay? And the following compound has a nitro group directly bound to an aromatic ring, is named as nitrobenzene. When you have alkyl substituent directly bonded to the aromatic ring, you could name this compound as an alkyl substituted benzene. In this case, this compound is named as propylbenzene. Typically, if you have an alkyl group directly bonded to an aromatic ring, and if the number of carbon in your longest continuous chain is short, like in this case, right? If the number of carbon equals or less than 6, and you would name this compound as alkyl substituted benzene. If you have more than 6 carbon, you would name this compound as a phenol substituted alkane. And your benzene ring is treated as a substituent and with the name of phenol. Under these circumstances, this compound contains 7 carbon in the main chain would be named as 2-phenolheptane. I did not have any stereochemistry included here, and really this carbon could be a chirality center. Then when you name this compound, make sure you also include the stereochemistry over here. If you have a carbon, acyclic carbon contains other functional group, it wouldn't be very convenient to name that as a substituent. Under that circumstances, you could again name your compound as the phenyl substituted compound. For instance, if you see a compound like this, and even though there are only 4 carbons in the acyclic chain and it contains a double bond, under that circumstances, you could name this compound as 1-phenyl 2-butene. Under these circumstances, you also need to identify the stereochemistry of the double bond, and in this case, you have a trans double bond, so you need to also include trans. Really, when you see literatures, the trans should be italic, but I'm just gonna save time, not worry about that detail. Okay? And in the aromatic compound, often you have more than one substituent, just like what you see earlier in the case of the orthoxylene. Right? So you need to identify the relative position of those substituents. Under that circumstances, if the substituents are on the adjacent carbon, we see these two substituents are ortho to each other, abbreviated in O. If they are further away from each other, they're meta to each other, and if they are even further away, basically on the two corners of a 6-member ring, they are parallel to each other. And the examples shown over here, including a (1,2) dichlorobenzene or O dichlorobenzene. Okay, and I should move this up a little bit. And the following example is a 1,3 dimethylbenzene or a meta dimethylbenzene. You could also name it as the meta-methyl toluene, right? Consider one of the benzene and methyl group. Consider the common name as one of the benzene and methyl group as a toluene, and consider this methyl as the substituent. And the following example has the chlorine and the aldehyde function group parallel to each other. It could be named as parallel chlorobenzaldehyde. Again, I'm going to move it up a little bit. Okay, and if you have more than 2 substituents, and you would have to identify the position of all the substituents. In this case, you want to make sure that your carbon number 1 always has a substituent bonded to it, and your second substituent also have as small as possible a number. And for this case, for this compound, and in order to make sure every substituent has smallest possible number, you probably should consider number this carbon as 1 and number the rest of the carbon counterclockwise as 2, 3, 4, and so on. Under that circumstances, you can name this compound in the alphabetic order for the substituents. Therefore, you're going to do 4 bromo, bromo, 1, 2, dimethyl benzene. Okay, move it up a little bit. And for the following compound, you could identify each functional group, or you may notice that this is essentially a substituted phenol. Phenol is one of the common names you need to memorize. If you want to name this compound as a substituted phenol, your OH needs to be bonded to carbon number 1. Okay, so in order to make your second substituent a smallest possible number, you're going to clockwise number the rest of the carbon. 3, 4, and 5. The methyl is bonded to a carbon number 5. Under that circumstances, the name of this compound would be 2,5-dimethyl phenol. Okay, move it up a little bit. And last but not the least, we have a tetrasubstituted compound. Again, to simplify our work, we notice that we also have a toluene over here. Okay, so what we can do is we can number the carbon directly bonded to a methyl group as number 1 because we want to name this as toluene. We're going to move on either clockwise or counterclockwise. In this case, they're the same. So your nitro group would be bonded to carbon number 2, 4, and 6. Therefore, the IUPAC name of this compound would be 2, 4, 6 trinitro toluene. Notice the name of trinitrotoluene. You find letters T, N, and T. So this is that compound that explosive and probably brings joy on 4th of July.